In this video, we will learn about von Neumann architecture. Von Neumann architecture. It was first established by John von Neumann in 1945. His computer architecture design consists of a control unit, arithmetic and logic unit, which is also known as ALU, memory unit, registers, and inputs and output. Von Neumann architecture is based on the stored program computer concept where instruction data and program data are stored in the same memory. This design is still used in most computers produced today. So this is our von Neumann architecture. It is generally architecture which we have already studied in fundamental of computers. It consists of different units, or you can say that different components, like there is input unit, processor unit and output unit. Processor unit is continuously in touch with memory unit from where it takes data and associated instructions. CPUs consist of three parts, that is ALU, CU, that is control unit, and registers. One human components in this architecture also tells us what are the basic components of one human architecture that help in processing data, that is converting data from input to output. That is first main memory in which we keep our data and instruction. Next we have CPU, main central processing unit. This is place where main processing takes place. It has three main components, that is ALU, control unit, and registers. So these are the units.
So up next we would move towards the registers. So what are registers? Registers are high-speed storage areas in CPU. All the data must be stored in a register before it can be processed. Registers are the fastest available memory and contains the temporary data and which is of very small size. So why do we use registers? Like, we have main memory, right? So what is the need of a register? The answer is speed. Registers are really quick. Meanwhile, the main memory falls slow, and all of our data which is processed in ALU needs to be very fast. For example, like A is equal to B plus C. This happens really quick in ALU, and main memory is kind of slow in comparison to that. And so the entire load of the operation falls on ALU. So what's the solution to that? Registers. Register speed are like almost similar to that of an ALU, so that there is no dependency on just the ALU for a random like.
So first of all, ALU. This is the main part of CPU. So the ALU allows us to perform various types of operation like arithmetic operation, logical operation, and relational operation. We also have some electronic circuit available in ALU like adders and subtractors, with the help of which we can perform addition and subtraction. We do have some division and ending operation also for logical operations, ending ring or exhaust or shift operation also. So all these electronic circuits are available in ALU. Another part of the CPU is control unit. Controller controls the operation of the computer's ALU memory and the input-output devices, telling them how to respond to the program instruction. It has just read and interpret from the memory unit. It maintains timing signals and control signals also. Timing signals will manage the timing, means that is what type of instruction executes first and what instruction runs next. Let's say in our program we have 10 instructions. Then what is instruction, what instruction has to execute first, and what in last. All these are basically managed by it. Let us take the example of driving car. The instruction for driving the car is, first of all, we have to press the clutch. Then we will have to change the gear. Then give a rise. We can't change this type of sequence of instruction or steps. We can't change this sequence. So to keep the track of this, we need a dedicated hardware. And that hardware is a control unit. So timing signals are basically used to generate timing. And at every timing, we have to perform one predefined action.
Thanks for watching. Please do share this video.